Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry. A topic is thermodynamics. And in this topic, this is lecture number 26. In this lecture, I will explain you calculation of delta E and delta H based on CV and CP and some adiabatic changes. Now we know that CV is equal to dE by dt. Okay, therefore we can say that dE is equal to CV dt, or for finite changes we write delta E is equal to internal energy of final state minus internal energy of initial state, and this is equal to CV into T2 minus T1, or final minus initial temperature. So for n mole of ideal gas, we can have delta E is equal to n CV T2 minus T1. So this is the formula used to calculate delta E if you are given CV and two different temperatures. Okay. Now for delta H we have another formula. Delta H is equal to delta E plus delta PV. So we write delta H is equal to delta E plus delta RT if n equal to 1. R is constant, so we write delta H is equal to delta E plus R delta T. Okay, or delta H is equal to CV into T2 minus T1 for delta E plus R into T2 minus T1. Therefore, delta H is equal to, CV is equal to, we can as R is over here, so we can make this T2 minus T1 common. So we write CV plus R into T2 minus T1, and CV plus R is equal to CV plus R is equal to CP. Therefore, another formula is coming, delta H is equal to CP into T2 minus T1. Okay, this is for 1 mole, and for n mole of ideal gases, we write delta H is equal to n Cp into T2 minus T1. So this is also one of the important formula to calculate delta H if you are given two different temperatures, moles of gases and Cp. Okay, so we can remember these two formulas to calculate delta E and delta H based on Cv and Cp. Okay, so let us take one numerical. Calculate the values of delta H and delta E on heating 64 grams of oxygen gas from 0 degrees Celsius to 100 degrees Celsius. Heat capacity at constant volume is 5 calorie per mole per degree, and heat capacity at constant pressure is 7 calorie mole inverse degree inverse. So we have to find out delta E and delta H from this given data. Okay, so here 64 grams of oxygen is given. So weight of oxygen gas, which is O2, is 64 grams. So number of moles of oxygen N is equal to 64 upon molecular weight of oxygen 32, and that is 2. Temperatures are given. T1 is 0 degrees Celsius, which is 273 Kelvin, and T2 is 100 degrees Celsius, which is 373 Kelvin. Now we have all values with us, so let us find out delta E. So delta E is equal to N CV T2 minus T1. Here number of moles are 2, heat capacity at constant volume is 5, T2 is 373 and T1 is 273. The answer will be in calorie, that you can calculate and find out. Next is delta H. So delta H is equal to NCP T2 minus T1. So here number of moles are 2, Cp is 7, T2 is 373 Kelvin and T1 is 273 Kelvin. So here also answer will be in calorie, and this way you can find out delta H. So these numericals are very easy. If you know all data, you can just put values and find out final answer. Okay. Now next topic will be adiabatic changes. You know, adiabatic change means dq. It is always, adiabatic change occur always in isolated system. And when it is in isolated system, there is no change in heat. There is no exchange of heat, in fact. And therefore, dq will be 0. Change in heat will be 0. Now, first law of thermodynamics. And we write a formula for this. dE is equal to Q minus W. Here Q is equal to 0. Therefore, dE is equal to minus W. Or we can write dE plus W is equal to 0. And you know that work at constant pressure P will be W is equal to PdV, and therefore, and for ideal gas, dE is equal to dE upon dt is equal to Cv, or dE is equal to Cv dt. So dE plus W means P dV is equal to 0 for adiabatic process, and now for dE we put Cv, so Cv dt plus P dV is equal to 0. So this is an important formula for adiabatic changes. Okay, and in this formula when adiabatic expansion is carried out, reversibly, so that P external will be 0 is equal to, P external is equal to pressure of the gas, and dV and dt have opposite sign. So if volume of gas decreased, temperature also decreases. So this way we can find out Cv or work done in this condition. Okay, that's it in this lecture. Thank you so much.